Integrating vector functions. Now this works exactly like you think it works. In single variable calculus, when we integrate, let's say a little f, I get big F as our notation. When I'm integrating little r, I get big R, and you just integrate each piece component by component. So if I'm doing this, integrate big, I'm going to get big R of, I'm integrating with respect to t, so I get integrate little r, get big R. Same as if you differentiate big R, you get little r. That's our notation. And now this is a definite integral. So it's going to be from a to b. And now that's just sub in the a parameter for t minus sub in the b parameter for t, top minus the bottom. Easy. Mechanically very straightforward. Conceptually of what it is, a little bit harder to think about, but let's just do this mechanically then. We want to integrate this vector function, summing up over t from 1 to pi. So it's a definite integral, so I'm going to end up getting a definite number. This r of t is each piece. Now I'm going to write out a lot of steps so we can see what's going on here. Integrating this just means integrate each function individually. So the first piece then is going to be integrate minus sine t dt. So that would be integrating the first component, integrating the second component, integrating the third component. Okay, I got to remember how to integrate ln t. That's an integration by parts thing, or maybe we just have the rule memorized. It's going to be then a vector. If I integrate minus sine, I get cosine. And that goes then, it's going to be sub in the top minus sub in the bottom. So from 1 to pi. Integrating t to the fifth, that's going to be an add 1 to the exponent, divide by what's up top. So t to the 6th divided by 6. Again, sub in the top minus sub in the bottom. And integrating ln t, that's going to be t ln t minus t. That's a rule that you know, or you can do integration by parts to check it out. And now all we got to do is sub in the top minus sub in the bottom. So cos of pi is minus 1 minus cosine of 1. Here I'm going to get pi over 6, pi to the 6 over 6. So sub in pi minus sub in 1. And lastly, sub in pi, that's going to be pi ln pi minus pi. There's sub in the pi. Minus, when we put 1 in, ln of 1 is 0. So this is 0 minus 1. Minus a minus 1 is a plus 1. There. Notice, integrate a vector function, get a vector function. If we differentiate a vector function, we get a vector function. Now here we get a constant because it was like a definite integral, so all these ones I get a definite number. If there were no endpoints on these integrations, it would be a plus c, and each component would get its own c, or it could be plus a constant vector at the end. And then you need some initial conditions, let's say, to figure out what that constant at the end was supposed to be. Integrating vectors work just like you think it is. It works just like it does in single variable calculus, except you do it with commas in between.